Let's come back. This is Elias sinkala. Please don't forget to subscribe, comment, like, and share. So let's continue where we ended with another episode, so-called partial fraction. Remember what was being said during division algorithm? It was the base of partial fractions. So here we go. So before I go any further, first of all, I would like also to raise an important, vital base of partial fraction. So I've got type 1 partial fraction, I've got type 2 partial fraction, I've got type 3 partial fraction. So there are up to 3 types. In terms of denominator, we've got the type 1 is linear factor. Quite interesting. That would differentiate what type of partial fraction I'm trying to solve. What about type 2? Type 2 is what we call repeating factor. Then type 3, the last one is what we call quadratic denominator or quadratic factor. So this entails the denominators. Denominator can be linear, repeating, and quadratic. This is a kind of expression, let me say entails, that is how to say, this is a type of partial fraction. So quite interesting. What about the expression if we talk about the type 1 and that is linear in terms of denominator? I put the f of x here as an expression, then divide by a plus x, or let me say x plus b, or plus a, then x plus b. So this is a linear expression of partial fraction in terms of denominator. What about the repeating? The repeating here we have, I've got f of x, then I'm going to have x plus e, then I can put 2 there, or 2 the root of 2. We're going to understand further what this expression mean, or what does each and every denominator mean under the forms of partial fractions. Let's go. What about quadratic in terms of expression? I've got f of x divided by, here the quadratic is the same equation that describe quadratic, or any equation that can describe quadratic, as long as that equation has got interpret quadratic equation, then that is a quadratic factor. For instance, I've got ax squared plus bx plus c. This entails also say this is a quadratic factor. Okay, let's go ahead in terms of forms of expression, or let me say forms of partial fractions. Then we understand better what this expression entails. So what this expression entails, this entails to say I've got a. Let me try to finish a quadratic factor here. We might have also x plus b in brackets, isn't it? So what this entails, this expression in forms of, or let me say in forms of partial fractions. This will be occupy a, use any letter that entails or that determine this, use any letter that you want, so that we separate this each and every linear factor and the denominator. So we say we're going to have x plus a plus b. Then b, that will be a differential operating sign each and every partial fraction factor, or let me say partial fraction. Then x plus b. So you can use any letter that you want. That is the form of partial fraction. Okay, here we go. Let's go now to the repeating factor. What will be the form? We're going to have a over x plus b, as in 1, going keep on increasing, plus b, x plus b, keep on increasing, that is number 2. So this entails we say there are 2x plus b, and this case there has to keep on what, increasing until it reaches up to what, up to b. For instance, if you had 3, would have also reached up to what, up to 3 in terms of form of partial fraction. What about quadratic factor? We're going to have a plus bx, a plus bx. This entails, or this describes the quadratic factor, or this entails amplify, or let me say simplify, or let me say interpolate the quadratic equation. So I'm going to have x squared plus bx plus c plus, so I've got a, b, then I'm going to have c over what? X plus b. So this is the table which entails or which describe all partial fractions equations, and in this case we'll be getting this kind of questions to answer each and every partial fractions. Thank you very much. See you in the next episode. Don't forget to subscribe, comment, and share. This is Elias sinkala. Thank you.